Alright, so the idea of today isn't anything particularly formal. It's not your usual formal talk. Today, I'm just going to make a basic functional web app in about an hour. If you have any questions about things, just stop me halfway through, because otherwise my mouth is probably just going to keep on moving and you won't understand them or we'll get left behind. Then it'll be confusing and everyone will be pissed off. So that's always nice. So I am using Clojure. Clojure is a lovely little programming language with a lot of brackets, which it's fairly easy to understand when we actually get into it. Maybe, possibly, we'll find out. Is anyone here actually trying to follow along with this, or I'm just going to go nuts and people are just going to watch me do some magic?
I'm trying to follow along.
All right. Well, if it's just you, you've already done some of this before, so I'm not too worried. Right, so better keep up. So, Line Engine is just a package manager. It's lovely. You throw in some magic words and the incantations, and it spits out some code. Fig Wheel, I will show you how that works a bit later. Light Table is the editor I'm going to use, and everyone can use this because it's genuinely just a nice little editor for this. And we're going to use Bootswatch to make things pretty because I'm lazy and I don't do styles. So first things first, we spit out some incantations. So Line Engine is the boot manager. We make a new project. It's of the Fig Wheel template. We'll call it Talk because I'm original, and Reagent because Reagent is the library we're going to use. Reagent is a wonderful little library that you specify some state, and then you specify a few functions, and whenever the state updates, the functions recalculate and spit out your front end. So you don't have to, it's basically React. It's a React wrapper, but it does some nicer things so you don't have to worry about putting in your own observers. Right. So before I even start this, let's go in here. Let's open up our new lovely little thing that we've just spat out a lot of stuff for. Okay, so in the talk, first things first, we have a project. You don't need to know crap about this for the moment. There's a lot of, as I said, incantations, etc. But we're going to open up a REPL. Do people here know what a REPL is? No, it's a read eval print loop. And they are very nice, and I will show you how that works in a moment too, because it's nice. So REPL is opened. We are going to now go line Fig Wheel. What this is doing, it is now starting up our own little web server, which will create its own WebSocket to whatever front end you put into it. And when you change code, it pushes that code directly into the browser. So anytime you change so remember how I said it goes state to functions to view? The state can stay the same. Anytime you change the functions, it puts that there and it goes to the view. So if you've done web dev before and you've ever had the whole thing of changing your view about 8 layers down through clicking through stuff, he knows what I'm talking about and has to do it all day. Instead, you can just have your state there, you change around the functions, the view updates. So you can just play around. The iteration time is very small. It's very quick and nice and wonderful. What are you doing? Yes, okay, cool, excellent. Control space, if you're using this, brings up your thing here, add connection, open up REPL, 7, 8, 8, there. Now we give that a moment to connect because that's going to be painful. Go. Okay. So remember how I was saying that it has a lot of parentheses? It's got a lot of parentheses. You'll get used to it quickly. The general thing with Clojure is that it's a Lisp, so it's always function arguments. I'll give it a moment to actually load up. So function arguments, the plus is your function, everything else is arguments. Yes, you can nest things, so you can go 3 minus 8, 4. Well, it'll give you 7, or it should when it actually loads up, otherwise you can call me a liar. The other thing is that it also, in here, I don't need you anymore, it opens up a web browser. You can have this in your own web browser and use your own setup as well, but this also works nicely, so we're going to work off this. Yada, yada. But while that's loading up, because I really hate styling, so from Bootswatch already, I've picked Darkly because I'm boring. You go download the bootstrapmin.css, and we'll grab that bootstrapmin.css, chuck it into our own. This is how you basically get something pretty up stupidly fast, because lazy and getting stuff done. So we have CSS file. Now we just have to change the, not you, just have to change the index. Let's change that index. So we have some CSS. Let's make ourselves some more CSS. If we reload this, hopefully it should come out nice and pretty. Yay! Awesome. Why are you not loaded? Go. Okay, cool. We have a REPL up. So it's just spat out a whole heap of blue text. Basically, that's just every single line, it will evaluate that. It'll send it to the REPL, which is currently running. It'll spit back the response. So there's the REPL actually has its own virtual machine running in it as well. So if we define some state, def, let's call it state. Why not? As 8. Cool. And we send that to the REPL. Now, even if we, well, I hope this works anyway. If we just call print line state, hopefully. God damn it. Okay, never mind. Doesn't quite work here because this is a JavaScript thing. It's probably doing the whole thing over and over again, but that's okay. Why are you not spitting out? Oh, this is going off to an excellent start. Anyway, whatever. We'll deal with you soon. So, anyone lost at this point, or are we just waiting to see what happens? You can keep up. You've done this before.
You were vastly overestimated.
Okay, I don't need you anymore. Okay, so we have this. This directly maps to here. So a square bracket is a vector. Fairly simple. The colon means that it's a keyword. The actual thing that's using it is called hiccup syntax. So if it says colon div, it's a div. It just literally maps to a HTML div. If we give it a class, so container, I think it's container. So we save that, we go here, and it should automatically update. It's now a container, which is why it's a bit more centered. Isn't that lovely? So next thing we have, so the other thing we have to look at is state. So Clojure by itself, everything is immutable by default, which is usually painful for actually getting anything done. But we have these lovely things called atoms, and atoms are things that you just put atomic operations on. So if we, let's do something a little bit different. So let's make a button. Actually, we need to make a button in here, don't we? Yes, we do. So we make a, so it's a button. It has styling of BTN and warning, because why not? And it has an onClick. Now, onClick directly maps to the onClick in JavaScript in your HTML, and you can attach a function to it because this is all compiling straight to JavaScript. It's lovely. So onClick, and we give it a function which takes no arguments, and all it does is reset. So reset takes 2 arguments. One is an atom, which in this case is app state from above, and a string saying I am reset. There, close off. So if I've done this right, we should see a button. Oh yes, I didn't put text in it. I should probably put that in there too. Yes, yes, I should do. Yes, and if we hit reset, oh, yes, I'm an idiot. Because you need to be under text. Right, try again, Logan. Let's not fail this time. Note that the state hasn't changed yet because because while all the other JavaScript around it, the actual atom hasn't updated because it's on a def once. So now we reset. Yay! Cool. We have state. Wonderful. Right, so what we're going to build today is possibly the most boring thing that I can think of that's also the most geekiest. And that is a D&D point-by calculator. It's geeky, it's boring, but it'll work. So let's do something here first. Init that state. Your initial state will look slightly differently from now on. So let's start with an empty map. And when you reset it, you will go to the initial state. Cool, and we don't care about you anymore. And yes, you'll get rid of you, I don't care. Yes. All right, so first things first, we need some stats. So what are our stats? It's our usual boring D&D stats. One thing we should also probably put in here, just down the bottom for our own sanity, is a div. All this will do at any time is print out whatever app state is at the present moment. So while we're doing this, what are you doing? Oh yes, should probably call it stats. Cool. Right, so this part here is currently what is currently in that atom. That is the state of the atom. If we reset this, resets to nothing because our initial state is currently nothing. Okay, so, yes?
You did your stats, you did colon strength, colon dex. What's the colon mean?
So colons are keywords. So I could do them strings as normally, but keywords have a couple of other nice properties in Clojure. One is that one of the big ones that you can use them as a function. So if you have a thing, let's just do this here. So if we have a map of, because maps can also be used as functions, but we'll get to that sooner or later. So we have A1, B2, C3. It's just a map. It's a map, curly braces, just a key val map. And if we go A, we get 1. Because all this is doing, it is performing that lookup on that map. So that's why keywords are usually nicer to use. Plus, they're a lot easier to write than strings are. And it's very obvious when you write them what they are. They're just a value, they're a lookup, they're something like that. That's all you care about. Rather than strings, which, yeah, they're strings, they're painful. Okay, so initial state. What is our initial state? Well, first things first, we need to have a stats, which will have a map. So what we need inside this map is we need a bunch of default values, and it's just going to be a mapping of keyword to value. So let's make something first. Let's define a function. Define stat pair. And this takes 2 arguments. It will take the default value, and it will take a keyword. And the reason why we and I'll show you why we put the default value first, but this just creates a pairing, which is keyword to default. Now, so if we do, yeah, send that to the REPL, you're in there, cool. Stat pair of, default first, 8 str. So that's what we're doing. We're making key val pairs. So maps, this is where the functional stuff gets fun. So because we're lazy and we don't want to write iterative loops, so we want to do a map. And a map puts a function over an array. So usually we could do a repeat 8 and then stats. Cool. Okay. Do people understand what the hell I just did there?
What does repeat mean?
So repeat just literally repeats the number 8 or that value over and over again. And map will just go to the shortest one that it's got.
So effectively it's just a function that returns 8.
Yes.
Okay.
Or it returns a infinite list of 8s.
Right.
But, so there's a slightly lazier way we can do this too, which instead of repeat 8, we use a thing called partial. Partial returns another function. This is disgusting. If you don't understand this right now, it's okay. So, does exactly the same thing. Because what partial by itself does, if we rip this out of there, it evaluates to a function, which we can use on anything. And of course, when you evaluate a function, you start it with open bracket function, but there's a double open brackets there because the first part of it evaluates to a function, which is then evaluated again to across string, and then that's what we get for one of them. So now that we're mapping this function across all of our statistics, we get 6 key pairs, each with the standard straight value of 8. So that's nice. Then the last thing we have to do is, we'll use reduce. Reduce merge. So reduce is the other big functional thing which is nice and fun. So reduce takes a long list, however long you want, and it takes a function and applies that function to the first and second arguments, or second elements of the list, and it creates a value, and then applies that to the third value, and then creates another one. So what merge is doing is it's taking the first one, which was str8, and merging in dex8. We now have another map, and then it grabs con, merges that in there. So you can do, so obviously this is a very simple example, but when you start getting into more convoluted things, you can do some absolutely stupidly powerful stuff that you never want to read again and debug. But you can do it. But no, reduce is actually really nice, and some other stuff gets really good with it. But, so we have stats needs to get moved after for declaration's sake. And then you are now our initial state. And stats. So our initial state is now, what am I doing? I'll type there, go. Yay! Hooray! So we have something there. So now we can manipulate some states and we can display some state. Now we actually have to display some state in a nice way. So what we're going to do is, where are we? There's the button, you go down there, I don't care about you. So we're going to make a table. We're giving it a styling of table, and that will do. And then each row needs to follow the same format. So it's a table row, and it has a TD of something like strength, and then another TD, which is 8. So just to start, so you understand what we're actually aiming for. Hopefully, yes. So we have one row of a table, but we need to generate this out nice and quickly. So, because this is functional, let's make a function. Defn create table row. And what create table row will do is it will take 2 arguments. Well, it'll take 1 argument, but we'll get to that in a second. We don't need a doc string here. Okay, this is a bit of destructuring. You don't have to quite understand this. Actually, I'll do it around the other way, because otherwise that's going to be painful. It takes a key val pair. And then we're going to do some binding. So we're going to bind the key as the, funnily enough, the key of the key value pair, when my thing catches up. And what do you think V is going to get bound to? The value of key value pair. Good to know we have a very captive and alert audience. So now that we have this bound, we can go, guess what? We have a table row. It will have a TD of the key, and it will have a TD of the value. And now that we have that, we actually have to do something with it. So this is where the fun comes in. So we're going to map, create table row. What are we going to do it against? We're going to do it across the stats. Remember how I was saying the keyword can look up something inside the map? We're going to look up the stats key inside app state. When my computer catches up. Yes, yes, yes. Hopefully I haven't messed anything up. Hooray! So now, we've already taken, so obviously you can make this data as big as you want, as small as you want, it'll just scale because it's a map. We don't care.
So can you rotate what app state? What's that?
Okay, so if we go, let's just do this. PRSTR app state. So app state by itself is of type atom, which means that, okay, that does this differently on Java. Okay, so app state by itself will not print out nicely, generally. At app state means we dereference the value that's inside of it. App state by itself is just a pointer to value. And then whenever you do an atomic operation, you usually do something. There's a whole heap of STM stuff behind it, which means that they're atomic operations. But don't care about that today. But basically, it's just dereferencing a pointer. So that's all we're doing. So, oh no, that's better. I dereferenced it there. So it says it's of a type atom with this value in there. So yes, so that is why it's an at. You can also use the deref function as well, but the at is just a shorthand for it and reads a lot nicer. So we have that. So the next question, so the next point of what we have to do is actually change some state within this table. I don't know if time. Ah, plenty. Plenty of time to bullshit about stuff. Excellent. So, yeah, that too. Okay, so the next thing we need to do is increase and decrease our values. So firstly, we have to do so it's going to be another TD, and it's going to have a minus on it. Come on, catch up. Yes, cool. So we have a TD, but if we click in this table cell, it's going to do something, and that is going to be one click. Yeah, come on. And it's going to take function. And what is this function going to do? It's going to do some absolutely disgusting stuff. So it's going to swap. So swap app state. So let's hold that for a second. I'll explain what swap does. So if we def a atom, which atom 0. Okay, so A is now an atom with the value of 0. And if we swap that atom with the function increment, yes, come on. Correct. Thank you. So it doesn't matter what the hell it is underneath there. You give it a function. You can also give it more args. So if we do a, remember that partial from earlier? Plus 10. So this function, so partial returns the function. And the plus 10, and the partial plus 10 means that it's going to, every time we do it, it's going to add 10 to whatever the value is there. And if we do this, it should go 19, 29. Yay! Hello. Glad we're actually working. That's what swap does. So now that we've got that, now we do the disgusting part. So we have swap, we have the app state. Now we need to give it a function. Usually you'd put this in another part, but I'm being a lazy dev, so don't usually do this in your code. So a function which takes the atom state. And what we're going to do is that we are going to update in that atom. Come on. We're going to update inside of that atom, inside the path. So update in a, and we are going to go down stats, and then we're going to go into our key, and we are going to decrement it.
Why do you need to put that A in the square bracket?
Sorry?
Why do you need to put that A in the square bracket?
Inside this square bracket, or this one here. Okay, so this part here, this entire part is declaring that this is a function. You have def-n above, which is a slightly shorter way of basically going def this variable name, this function. So fn, if we declare a function here, note the double brackets because we're going to evaluate this afterwards. We put this function here which takes anything and adds plus 1a, right? This thing here is an increment function. It just takes whatever, puts it in there, and we give it a 3, it should spit out a 4. Or I could just break things because this thing's not yet finished. Okay, yeah, what are you doing? What are you doing? What are you doing? Oh, okay, there we go. I just had to catch up. Okay, so does that make sense? Yes, no? Okay, cool. Or alternatively, you can also do, but yes, that's what function does. You can also put a partial in there, you get the idea. Okay, and if I've done this correctly, which I probably have not, but we'll find out in a moment, these should, hey, look at that. So each time I press this, it is swapping out the current value that's in there using that function, so it's decrementing whatever key I give it. But this is a problem because by point by, you're not supposed to go below 8. So consequently, we need to do something here. So I'll put this code up later, by the way, if you're worried about it. So now we get to some more tricky functional crap. So there's a thing called comp or compose. And what compose does is you can chain together different functions. So if you would have one function that takes something in, it then chains to the next function, to the next function, to the next function. So if we want to, let's do the trivial case. Increment and decrement a number. What does that do? Absolutely nothing, but it proves the case. On 0, this will return 0. We increment it twice, returns 2. Annoyingly, it does it from right to left. So the right-hand one will take place before the next right one, the next one from the right, the next one from the right, the next one from the right. Yeah. There is also another way to do this slightly differently, which is the thread first macro. This is kind of a bit weirder. So thread first takes whatever the first value is and then puts it into the next body. And then as the first argument, and then evaluates that and puts it into the next one. So if we go, we want to increment this, then we want to increment again, and then we want to make it a string, and then we want to, oh, that'll do for the moment. So what this is doing is it's taking the value 0, putting it into an increment, which goes to 1, takes that value, puts it into an increment, goes to 2, then puts it into a string, puts it as a string. Don't really need to know this at the moment, but it's just some funky macro stuff that can make your life much easier later. And yes, you're not expected to know this. There will not be a test later. This is just showing some of the random tricky shit that you can do if you start going into this space later. All right, so we have that. So that compose, we have a decrement function. We want to compose it with something. What are we going to compose it with? You have 2 numbers, and you want to make sure there's always a ceiling on one of them.
Oh, max. Oh,
Max, yes, correct. So we go max of 8, because we always need to be up there. But of course this won't work, so what's it need to be? It needs to be a function, which means it's got to be partial. I'm quite partial to my partials in case you hadn't noticed. I've had a long day, sue me. And then hopefully that compiles, and look at that. It will no longer decrement past 8. And just to prove that it is working, and because I'm being naughty and not actually abstracting my functions properly, we're just going to do some copy-paste. And the other side is this will be a min. It will be as 15, and we're going to increment this, and we're going to give it a plus because it's got to look at least somewhat pretty. Well, it doesn't have to look hugely pretty, it's still going to be ugly, but hey. And now, we can increment numbers, and it will go up to a max of 15, and then we can fall all the way back down again. Okay, cool. So now we have some basic state changes. So the next thing we need to know is know exactly how much point by we're actually using. Because otherwise, what's the use of it? I promised a point by calculator, you're going to get one. So, because this is functional program, we're going to use yet another function. So define a function, calculate point by. And it's going to take one argument, which is a number. And all this is going to do is spit out the value of whatever the hell we put into it. So it's a case of n. If it's an, I'm being horribly lazy, there's probably an easy way to do this, but I don't care. So case of n, oh, what am I doing? That. It's a function, remember, it has to start with the parentheses. So case of n, if it's an 8, it gives 0. If it's a 9, it gives it 1. If it's a 10, it gives it 2. 11, 3. Ugh, what have I done? Yes, this is boring, I apologize. Glad you're spending your afternoon watching someone do data entry. 13.5, it's a 14, it's a 7, and if it's a 15, it's a 9. And if it's anything else and you manage to break out of what the hell I'm doing, I'm going to set it to 100 and say bad boy. Come on. No, 100. 100 computer. Unfortunately, my laptop is not particularly good at simultaneously running a JVM, or running a JVM, a JavaScript compiler, and also at the same time recording a screencast. It's not particularly good. So we do that. What have I done? I haven't closed it off, have I? There we go. All right, try again now. Excellent. So if we go... Yes?
Why did you go 13, 5, 14, 7, 15?
Because if you have particularly higher stats, it's meant to cost more. That's the way that the official 5th ed does it. I don't really care. I don't touch 5th ed. But I figured some people might actually be able to use it, so there you go. So if we do it on 8, it should hopefully return, or, come on. If we do it on a range, actually. So we'll do it from 8 to 15, or 16. If we do that, I need to map it. Of course I need to map it. But it returns 100 because it doesn't find any value in those ranges. So look at that, lovely. So the numbers 8 to 15 are working nicely. And so now, if we're on our create table row, you should probably figure out what's coming next. So what we're going to do, we're going to have a table cell. And what's it going to display? Calc PP of your value. And hopefully, come on, close off. There we go. Right, save that. Give it a moment. Look at this. And note that there's been no worrying about setting up observers or managing any other state. Reagent does it all for you because it's wonderful. All right, so we have this. Now the next part is just to add everything up. And adding everything up is nice and easy, and that lovely little bit at the end. So we've got that, we've had our table. And the last thing we need is let's put a div in here. And what it's going to say is that total point by is, so remember that thread macro I said before? This is basically the same thing, except it chucks in as last. So we take app state, we get the stats. Sorry?
How's that work again?
Okay, so thread first puts it as the...
It chucks it as the last argument.
Yeah.
Right.
Yeah, so if you have a body of stuff, this puts as the last. Anything that you're doing collections with, you always use it as the last argument. And we're doing collection stuff here, MapReduce good stuff, so we're using the thread last. So app state into stats. Let's put this above and I can demonstrate what this is doing here. App state into stats. Oh, what are you doing? What do you mean it's not a valid keyword? We're experiencing technical difficulties. No.
Maybe do it again, but
No, possibly, I don't know. God knows this computer is a piece of crap, but that's okay. Let's just reset you anyway, just to be sure. Alright, you're going to work nicely this time. You're still a string. Why are you? Oh, that's right, because I printed you as a string. Okay. Now we should. Okay, cool. We have stats. So that's what we're at. Now we want all the values. Yes, all the values from there we have. And then what are we doing next? Sorry? Not quite, because we need to get the point by values first. We need to map, because we are doing something to everything in this array. Yes, for when if at any time you're going, I need a for each loop, or a for loop, you use a map. It's much easier. So we map, calc PB, calculate point by. That comes out zeros because, yes, of course it does, because we haven't done anything here. So let's give ourselves some bigger numbers. That'll do. So now if we do this again, look at that. We have, and that should match up with 52035. Excellent. So now we have that. Now we add them up, which is close enough. It's a reduce. I think there is. No, there's not a basic sum function because that's exactly what reduce plus is. Look, we have 20. So this entire thing here, which you can put in the function if you really want, but I'm not going to because I'm being a bad dev, will go into here. Look at this. We have a total point by, which means that now you can build, do whatever the hell you want, yada, yada, yada. All right. There we go. We have a very basic functional web app in, oh, Jesus Christ, 35 minutes. All right. What the hell are we building on this thing next?
The cap on the point
No.
I've been looking at that.
That involves actually doing some other, unless, oh, okay.
Calculating the modifiers.
Hang on. We can do the modifiers shortly. But so there's atoms have some other actually cool stuff on them. I need to look this up first so I know what the hell I'm doing with this. Clojure docs, come to the rescue. So atoms can have validators on them. And validators are just functions, which must always be true. Validator. Atom, X, and options. Okay, so it goes afterwards. So this is where things start falling down because I screw something up. But that's okay. Let's try it anyway. So there's our so that's an atom. That's our value. The next part is validator, and it will take a function which takes one number, and it must be between 8 and 15. Wait, no. What the hell are we doing? No, we don't care about this, do we? That's doing each one. No, okay. Okay, we do need to put that in the function. All right. Look at what you've done. Okay, so this thing here. Ooh. What are you doing to me? What are you doing to me? All right, calculate. So we need to define a function which is calculate total point by, and it takes an atom state, and it's just going to do this. But instead of app state, it's just going to take A. Okay, and then hopefully, now that we've defined that, the moment of truth is that if we put calc total point by on this thing. Okay. Oh, you're taking me off script here. Okay, now I have to think about this on the fly. What are you doing to me? All right, so this function will take the atom state here as well, and it has to ensure that this thing here is less than or equal to 25, and this, so that we calculate the total point by of, yes, negative, because we only have to dereference it if it's an atom. We are passing a value into this. We're correct, I think. Let me check and make sure. Nil side effect free function, one argument which we pass the intended new state. So whenever it changes, it'll run this validator, and if it runs true, it should be true. Should return false or throw an except. Okay, so if this is true, everything is good, carry on. And watch as everything breaks. Look at that, told you. Where the hell is that at? Calc. Oh no, it's because this is here. It's a matter of ordering. Because it evaluates them one after another. Which means you can have timing issues, but that's okay. Okay, right. Let me reset this. All right, now we need to change this back to a def once so we don't end up overriding a state every time we save again. And if we're really lucky, this will work. Otherwise, it's just going to fail miserably and I'm going to sit here and get pissed at it. Nope, it's failed. Excellent. Why are you not throwing an error? What are you not doing for me? Or did I not call it the correct thing? Yeah, validator. No, whatever. Deal with this later. Anyway, that's supposed to work. It's not working. Don't know. Don't care. Let's put this in here. You can do two things. That's okay. Side effects. No one ever got done to side effects. Because you're not running the validator function. Did I not call it? Oh, well. Whatever. Anyway. Modifiers, let's do that instead. Oh, because something hasn't closed off properly, has it? What have I done? 23. How do you mean? I did everything. Your work. Why are you not working? Alright, whatever. Well, it's not printing out, so probably not. But whatever. The validator's not running, probably because of, have I spelt it correctly? I don't know, I don't care, whatever. Let's move on. Validator. No, not working. Stuff you. Okay. Never mind. That would have been cool if it worked first time. Alright. Instead, you want to learn modifiers. Okay. So first things first. What's it going to be? It's going to be a function, because everything starts with a good function. Calculate mod. So it will take a number, and what are we going to do with this thing? How do we calculate modifiers? You should know this. No? You don't remember how to calculate modifiers?
2 after 8, I believe. 8 plus something.
No. A 10 at 0, remember?
Yeah, 0.
So we subtract 10 from it. Remember, this is thread first. What are you doing? This is thread first, so the n will go in the middle as the first argument, so we'll go minus n10. Yes? Cool. Then the next thing we need to do is divide by 2. And then we're probably going to need a math.floor. What's up?
Okay. Rules of D&D are strange and mysterious.
I ran D&D for many, many years, so this stuff's like back of my friggin' burned into my forebrain. So now if we do this and we actually check it to make sure, we let's just... Sorry?
How badly is it going to break when you're not this
No, it won't break, because remember that 10 will go as this argument. This means that it's a thread first, which means it goes as the first argument. If I was doing this, then everything's screwed. Well, it'd still kind of work, actually. No, if it was 10, it'd still break. But yes, because this is the first argument, it goes minus 10 minus that number, then divide it by 2, and then do math.floor. And we can coerce it to an int at the end, just to be sure. And if we calculate mod, and we do it a range from 8 to 15, it's exclusive at the top.
How
This
would
should...
you handle it if you didn't have the math.floor? Like, what's the sort of expected behavior?
Blah. Oh, yes. Try again. Okay. So 8, 9, 10, 11, 12, 13, 14, 15. Seems to be working nicely.
So is that Clojure math.floor or is that JavaScript math?
That's the JavaScript math.floor. Because we can do interop. Isn't that wonderful? Yes, you can do any JavaScript you want from ClojureScript. Of course, don't go heavy with it because it's kind of ugly when you start getting into it too much. Mainly because JavaScript is ugly. But that's an argument for another time. It's a holy war for another time.
I inline JavaScript, my closure script.
All right, so, and then what are we doing here? Exactly the same damn thing again.
No, we need to do complete JavaScript app in ClojureScript and not even have closure. That sounds like a good idea.
It's called a wrapper library.
Called me a bad person.
All right, so what are we doing? We are just calculate mod on V. What are you doing? There. Look at that. We have modifiers for each of them. I should probably put that as the first column, honestly. Let's face it. We don't want this last column. Your value, and then your mod.
Can you add headings?
Sure. We just need one row. Right. TH value. So mod. That should do. I'm lazy. No? Why not? Oh, right, because you're not in the... That's a table row. I'm putting that in the wrong place. That would help. You, go there. All right, the reason why that did nothing is because functions only return the last value. So because it was designated as two separate values, the first one technically calculates and then he goes, ah, piss off, I don't want you anymore. Look at that, stat value mod, and a couple of buttons, and the total point cost at the end, which I can't be bothered doing right now. Where are we? We've got a little bit more time. Anything else? What else can we throw into our...
Your minus plus and three buttons.
Oh yeah, that's actually quite easy.
CSS.
Okay, so pickup syntax is also wonderful. So we have a table cell, and we want to put a button inside of it. Button dot btn. So it's a lovely. Come on, catch up. No? Yay!
Yeah.
I'm never recording on this thing again. Right. Button. Isn't that nice? And we can make it smaller. This comes with the boot swatch. This is why I put it in there and recommend it, because it just has a whole heap of really nice stuff that you can just pull out and go, you're mine now, thank you. It should, let me catch up, it's a smaller button. These are in different things, so let's put these into the same thing. Come on. God damn. Hope you appreciate that my computer is dying for your sins. Sorry? Yes, that is the fan you can hear. Look, the computer was cheap, all right? Run with it. Right, so that's to there, to there, to there, and then we just have to close off that. And let's indent this because this is... Aha, look at that. Hey! And we can also, if we want, put this inside a, it's a type of, is it a div? I think it's a div dot button group. And if I'm right, this will change the styling. Yeah, it's catching up. Look at that, removes the things between them. So now we have buttons, because buttons are fun. Exactly. Well done. You can implement some basic CSS. Yeah. Anything else? What else can we throw in our functional web app? Yes, they can nest as many times as you like, and it means you don't have to close off the other end.
What changes did you make the button?
Sorry?
What changes did you make?
There was a little bit of rounded corners in between here. That literally just, hang on, I'll remove that again and I'll show you. Let's just comment it out. Why not? Super lazy. And when it updates, you'll see it change there. That's literally all it does. But it looks pretty, so it's staying in there. What the hell did I do? Wow! What are we doing? We're good? We're good. I think we're okay. I don't know what the hell just happened there, but we'll run with it. We're good? We're good. Okay. All right, how much time we got? We got a little bit longer for one more thing. The hell are we going to put on this thing? Anything else anyone can think of?
Fixing your total point by.
All right. All right, let's wage war with this thing.
I check your usages first because you expect to throw an error.
This should be printing something out to console. Let's do... So, if we grab... Let's grab this. Let's do some nastiness and see how this works. Swap, 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 swap. Update. Swap app state. What are we swapping? We are swapping in, let's do str. And we're going to remove this limitation and we're just going to increment it a few times. Right, so swap by itself will return the value that you swapped out. So you don't have to worry about swapping the value, then getting the value. The moment you swap it out, it will return that value. So let's define this atom there. And then if we increment strength, all right, you're going to go from there. Sure, why not? And then we should print line of, is this printing to console? Let's hope it is. I think it is. It should be. I don't know. No, it's not printing to console. Okay, right, fine. That's probably why. Print string of total point by of app state. Right, so you're at 4. You should be at 5. Remember what happens whenever we got above 15? Right, okay, that validator is just not working at all. Fantastic. Atom. No, it's not going to happen today. I don't know why this isn't doing it, but it's probably something stupid that I've done somewhere and don't know about it right now. Whatever. We might call it there then. Sorry? Yeah, it's failing. It's not going to work. I'm not going to sit here and try and debug the stuff in front of you for a while. But anyway, that is... Sorry?
Just on the note of atoms, so when you dereference the atom, it's taking a copy of the state inside the atom, so if you change...
Everything's immutable! It's never going to change. So because it's never going to change, you can just point straight to it. There's no need to copy it. So anytime it actually updates or creates or swaps or does something else with it, it just makes a new copy and it just points it here. So if you've still got this bound, it's never going to change. It's fine. It does some other tricky stuff under the hood where it doesn't copy the entire tree. It just copies exactly what it needs to. But that's B trees and all sorts of other absolutely fun stuff that's going to take way longer than now to explain.
In an atom, can you have just like any state?
Whatever value you would like. You can even put other atoms in there if you really want. You shouldn't do it, but you can. But you can have very complicated nested trees. And basically, at this point, your atom, you have a single atom that becomes a state machine. You just have a very big state machine that just does everything for you. And you can get some very complicated state machines. What's up, Jack? You look confused.
I'm just thinking about the references of atoms inside atoms.
Yeah, no, don't, just don't. Don't go there.
It's a very bad thing to that.
And if you really want, you can have an atom that references an atom directly that references something else.
That's what I was thinking.
Don't do it. Just because you can does not mean you should.
Yeah, I know that.
All right, I will leave it there then.
Awesome. Thanks, Logan. Everybody keep up for
Any other questions before we get out of here?
Yeah, do you want to fix mine?
I will.
I got a reagent error like at the very start, so I stopped.
I will put this code up online for people to have a look at and have fun with when I get home tonight, and I'll link it in events for people.
Can you just copy paste that the code.js?
What's up?
Can you copy paste code?
No, not you. Behind.
You reckon those brackets?
If you're being a bad dev, I think you can get about 8 or 9. Don't be a bad dev.
I mean, you know that.
Yes, I know, I am a bad dev. All right, I'll stop the recording.
That'll be the end of the recording. I'm a bad dev.
I'm a bad dev.